Alright guys, I'm going to make a video going over the odds of the review, and then if you need help with any of the problems other than the odds, the evens, then you can let me know on an individual basis, okay? I know I have a due date on the calendar for this review, but if you need to take a few days, it's perfectly fine. The only people I need to turn in grades right away for is seniors, so. Okay, here we go. Number one is, let's see, let me get this a little closer. So number one says solve 5 plus tangent squared equals -2 tangent plus 4. And we're solving that for all the solutions for thetas between 0 and 2 pi. So 0 and 2 pi. Okay. I need my, where did I put my, I realize I'm talking to myself, and that is okay. Oh, there it is. I need my unit circle. Okay. So what I'm going to do is I've got a quadratic tangent, I've got a linear tangent, it's got a power 2, power 1, and I've got some constants. So my thought is I'm going to need to get everything on the same side and factor it like a quadratic. I'm going to put it in order at the same time. So tangent squared, 1 tangent squared. I'm going to add 2 tangent theta over, and then I'm going to subtract the 4 over, and that leaves me with plus 1 equals 0. So I'm looking for the factors of 1 that add up to 2, and that's 1 and 1. So that would be tangent plus 1 times tangent plus 1, or tangent plus 1 quantity squared, right? So the factors of it, I'm treating it like an x squared plus 2x plus 1. Factors of 1 that add up to 2. Okay, so I really just need to know when tangent theta plus 1 equals 0, or when tangent of theta equals -1. So as far as tangent equaling -1, tangent is sine over cosine, right? So it's when, the only way that you're going to get 1 is when you divide something by itself, and the only way that you're going to get -1 is if one of those is negative and one's positive. Square root of 2 over 2 and square root of 2 over 2, if I were to divide the sine by the cosine, I would get 1, but I need -1. So I'm thinking right here, one of my answers is going to be 3 pi over 4. And this one right here, they're both negative, so that would simplify out to a positive 1, whereas this one over here, at 7 pi over 4, negative square root of 2 over 2 divided by positive square root of 2 over 2 is also -1. So 3 pi over 4 and 7 pi over 4, and that's it. I don't have to do it twice because it's the same answer, so there we go. Alright, number 3. Number 3 says cosecant theta times secant theta equals square root of 2 cosecant theta. Okay, so I've got two different functions going on here, cosecant and secant. I do only have 2 terms in that, like I've got this term with a product and then this term with a scalar multiplied by a cosecant. So what I want to do is I want to get them on the same side. Cosecant theta times secant theta minus the square root of 2 cosecant theta. And then I need to treat it as if it's just where I'm finding the common factor, the greatest common factor, and I'm going to factor that out, okay? Sorry, I'm trying to still figure out this camera. It's being weird. Okay. They both have a cosecant in them, so I'm going to factor a cosecant out, and I'm left with secant of theta minus the square root of 2 equals 0. Zero product property says that I'm multiplying 2 things. If one of them is 0, then the whole thing is 0. So I need to figure out when cosecant is 0, and when secant of theta minus the square root of 2 equals 0, or when secant of theta equals the square root of 2, if I add that over, right? Well, so here's the thing. If cosecant is 0, then that means its reciprocal sine is 1 over 0, which is undefined. And here's the thing. If you think about the sine wave, it's never undefined. So this has no solution to this part of the problem, okay? Cosecant will never equal 0, and if you remember the cosecant wave, it looks like this. It never hits the x-axis, so cosecant's never 0. Now, secant equaling the square root of 2 means cosine equals 1 over the square root of 2, and that rationalized is square root of 2 over 2. So I'm looking for when cosine is the square root of 2 over 2. Cosine is the x, and the x is only positive on the right-hand side of the unit circle. So I'm looking right here at pi over 4, when cosine is square root of 2 over 2. And at 7 pi over 4, when cosine is square root of 2 over 2. Okay, let's go to number 5. 5 says solve 3 cotangent squared theta equals 1 plus 2 cotangent squared theta. Okay, so far I've had, this is my third type of problem. This one had a quadratic tangent, a linear tangent, and constants. That's a quadratic form like a ax squared plus bx plus c. Then I had this where I had a cosecant and a secant and a cosecant, so I had 2 terms only, and they had a common factor, so that was just factoring out the common factor. Now I've got this situation where both of my cotangents are squared, and then the only other term I have is a constant. So that would be like me asking you to solve x squared equals 2 minus 7x squared. I'm going to add the 7x squared over there, combine them, and then it's just a matter of solving for x, and I'm going to leave the 2 over there because all I got to do is solve for the x term, right? I'm going to subtract 2 cotangent squared from both sides. So if I subtract 2 cotangent squared, then what I'm left with is 1 cotangent squared, so just cotangent squared equals 1. I'm just going to bring the constant down. Now you could say minus 1 equals 0 and move that over as well, but you're just going to move it right back over, so no real point. Now what I got to do is solve for cotangent, so I got to get rid of the square, and the inverse operation of the square is the square root. You just got to remember that when you take a square root, there are 2 answers, both plus and minus the square root of 1, which means plus and minus 1. Now, I don't tend to look for cotangents on the unit circle. I tend to look for the reciprocal tangent. So remember that if cotangent is 1, then tangent is 1 over 1. If cotangent is negative 1, 1 over negative 1. So it's still just plus and minus 1. So I need all the answers when tangent is both positive and negative 1. Tangent is 1 at pi over 4. Tangent is negative 1 at 3 pi over 4. Tangent is 1 at 5 pi over 4. And tangent is negative 1 at 7 pi over 4. So it is at all of the quarter pies. 1/4, 3/4, 5/4, and 7/4 pi. And there we go. Okay, let's go to number 7. So number 7 says 0 equals the square root of 3 times secant of theta minus 2 tangent of theta. Okay, so this isn't an obvious situation, and it's not similar to any of these right off the bat, but what I'm thinking is tangent is sine over cosine, right? So I'm gonna play with that for a second. I've got negative 2 sine divided by cosine. This is a secant, which is the same thing as 1 over cosine. So if I can bring this up as a secant, then that means I've got a common factor of secant that I can factor out like I did in we factored out a cosecant, but similar process like we did in number 3. So what I'm going to do is I'm going to rewrite this. I'm going to say 0 equals the square root of 3 times secant of theta minus 2 sine times secant. So I'm going to bring that cosine up as a secant. And then I've got 2 terms, this term and this term, and they both have a secant in them, so I'm going to factor it out. And in fact, I'm going to move the equals 0 to the other side because it doesn't matter. So I'm going to factor out a secant, and I'm left with the square root of 3 minus 2 sine equals 0. So I factored a secant out of both sides, and I moved the equals 0 to the other side. So I need to know, when does secant equal 0? And when does the square root of 3 minus 2 sine of theta equal 0? Or when does sine of theta equal? So I'm going to skip a step or 2 in my head. I'm going to subtract this over, negative square root of 3, and then I'm going to divide by negative 2. So negative square root of 3 divided by negative 2 is positive square root of 3 over 2. Okay. So let's talk about this again. When is secant 0? Well, secant is 0 never, because cosine is never undefined, right? So cosine would be 1 over 0, and it never does equal that, so there is no solution for that part, okay? Over here, when is sine the square root of 3 over 2? Sine's the y value, so we're looking at the top 2 quadrants being positive. Sine is square root of 3 over 2 at pi over 3. And at 2 pi over 3. That's where sine is the positive square root of 3 over 2. And there is my answer. Those are my answers. Okay. Here we go. is we're going to solve 2 cotangent theta plus 1 equals negative cotangent squared theta. Okay, so in this case I've got a linear cotangent, a constant, and a quadratic cotangent. This is reminding me of the quadratic form in the first problem, number 1. So what I'm going to do is I'm going to get everything on the same side. I'm going to make the cotangent squared be positive, so I want to move that over here. I always want my quadratic term to be positive. Cotangent squared plus 2 cotangent plus 1 equals 0. And in fact, it's the same quadratic as up here. Tangent squared plus 2 tangent plus 1, in that, you know, you've got tangents versus cotangents, but it's the same factors. I need the factors of 1 that add up to 2, and that's 1 and 1. So cotangent plus 1 times cotangent theta plus 1. So I really just need to solve when cotangent of theta plus 1 equals 0, or when cotangent of theta equals negative 1. And to be honest, cotangent equaling negative 1, the reciprocal of that is 1 divided by negative 1. That's still negative 1, and we already answered that question in number 1. So the solutions are the same, 3 pi over 4 and 7 pi over 4. Okay. Let's talk about numbers 11 through 14. Those are giving some people some trouble. What we're going to do is we're going to find, it says solve each equation for all solutions on the interval from 0 to 360 degrees. So that's important because now we're in degree mode. So number 11. Negative sine squared theta minus sine squared equals negative 2 sine squared 2 theta. Now this is one we could work out by hand. Sorry, you can't see it. Sine of 2 theta is 2 sine theta cosine theta, so I could definitely square that and then factor out a sine squared. We could work it out. But if I'm telling you to solve it using your calculator, then what you can do is do this. So the first thing I'm going to do is I'm going to go to mode, and I'm going to make sure I'm in degree mode, and I am. Okay. And then I'm going to turn on the lamp, see if I can. Let's see if I can move this out. Move this over. Will it help any? I don't know. Probably not. Okay. I'll try to hold it where there's not so many shadows. Alright, so what I'm going to do is I'm going to go to the window. I want to solve for all the angles, so theta is going to be my x, right? I want to solve for all the angles between 0 and 360. And I say we go by, I don't know, 60 degrees. So that's just my scale. It doesn't really matter if you have that. Now my y window, let's keep in mind that these, like, trig functions, sines and cosines, they tend to stay kind of close. So I'm going to go negative 3 to 3, and if I need to go higher or lower, I can. But I'm just going to keep it like that. I'm going to go to y equals. And I'm going to type in negative sine squared. So in order to type in sine squared, what you do is you type in negative sine of x. It doesn't have to be a theta. This is just the variable. And then after that parentheses, you square. Because what that parentheses is closing is the sine operation, not the x, okay? If you typed in x squared and then close your parentheses, that would be completely different. So I'm going to graph that. And I'm also going to graph negative sine of 2 theta squared. Yep. And I want to graph and see where they intersect. So I'm just going to press graph. And I've got one side of the equation. And then it looks like I have the other side of the equation. Okay. So what I need to do is I need to find all the intersections. Now I will say it looks like they're intersecting at these points right here, which I know are 0, 360, and 180. And I'm going to go ahead and make sure right quick. If I go to second calculate, so if I go to second and I go to calculate and I do value, right? So if I'm calculating the value and I type in 180 degrees for x, it's going to tell me that y1 is 0. And if I go down, so I press the down arrow and now I'm on y2. I don't know if you can tell. So I'm on y2 right now, and it's also 0. So y1, gosh, I hate that it's so blurry. And the lighting is terrible. Okay, so this is y1, and it's 0, and then y2, if I go down, it's also 0. I'm pretty sure the same thing can be said for 0 and 360. And here's another way to do this. I'm going to go to my table. Now, I have my table set up such that I can type in whatever I want, right? You do that by saying, go to second table set, right here, and on independent, go to ask, okay? And then I'm going to go back to my table, and I'm just going to type in 0, and I get the same thing. 180, and I get the same thing, and 360. So I'm just making sure that those are answers, that those are intersections, because sometimes those are harder to find. Okay, now, here's what I know. I know that these two graphs equal each other. Let's see. Looks like they intersect 1, 2, 3, 4, 5, 6, 7 times, right? So it looks like I need to find 7 intersections, although I'm pretty sure, I'm not pretty sure I know. I know 0, 180, and 360 so far. So I'm going to go second calculate, and I'm going to do intersect, okay? Now, so second calculate, intersect. Whichever intersection, so here's one intersection, right? Whichever intersection the Blinky Dude is closest to, that's what he's going to find. So I'm going to press enter on first curve. It jumps to the other curve. I press enter. It says guess. I don't care to, so I press enter again. And I get 60 is the x, right? So that means the first angle is 60, other than, starting at 0. In fact, I want to see if it finds that intersection. I'm going to go over here and press enter, enter, enter. It's thinking. Yeah, it doesn't like that. So what I want to do is, for those, I'm just going to go ahead and use my knowledge of like the units that I said. Here's 0, here's 360, there's 180. And I use the table to make sure, and I'll show you another way to work this if you are uncomfortable doing that, okay? Okay, so we've got 0 degrees. We've got 60 degrees. Okay, I need to find the next one. So I'm right here. So second calculate, intersect, number 5. And I'm going to make the Blinky Dude get close to that intersection. So he is over here, closer to this one. So press enter, enter, enter. And 120 degrees. So far it's been 0, 60, 120 degrees. I know 180 degrees is that one in the middle, right? Not that you can see that. And so I'm going to find this one. I'm pretty sure, keeping with how it's going to go, I'm pretty sure that's 240. So second calculate, intersect. There's my dude. Okay, so he's over here. I need to move him over there. So enter, enter, enter. The closest intersection is that one right there, and it finds it, and it is at 240. So 240 degrees. I'm pretty sure the next one is going to be at, let's see, 300 degrees. Second calculate, intersect. Okay, closer to that intersection, so enter, enter, enter. And I get 300. And the last one is 360. Okay, so all of the answers between 0 and 360. I guess I didn't include 360, did I? So we're not going to include 360 because it's just a repeat of 0. Those are all the answers. 0 included, 360 not, for which negative sine squared equals negative sine squared of 2 theta. Okay, here's another option though. If you would rather find zeros instead of intercepts, what you can do is you can add this over to this side and have just one equation, one function. So I'm going to take this and I'm going to delete this. And at the end of this one, I'm going to add the sine of 2 theta squared. Okay? Now when I graph this, I'm no longer going to be looking for intersections. I'm going to be looking for when the whole thing equals 0, right? So when I look at this, it looks like I've got 6 zeros. I've got this one, 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 I've got that one. And by 6 I obviously mean 7, right? 1, 2, 3, 4, 5, 6, 7. Yes. Okay. Now here's another problem. If I do second calculate and I do 0, it's going to find this one because I have to go above and I have to go below. But if I try and find this one, because it bounces, if I press enter and then I go over here and I press enter again, it's going to say no sign change, and it's not going to find it for me. I'm pretty sure. Yeah, no sign change. Okay. So, as far as finding your solutions, it's not a, it's not a bad idea to use your table and to type in what you think you're, if you think it's like halfway between and you want to check, then type in 180 and see if they're the same value, okay? You can also do that in the home screen. You can do, well, I'm going to go back to when I had everything in, or two different equations. Okay, come on now. So negative sine of 2 theta squared. And in the home screen, I can do alpha trace. And I can do y1 open parentheses at 180. Press enter. And then do y2. So alpha trace y2 at 180. So open parentheses 180. And this is just like function notation, f of. So you're plugging 180 in and you get 0 for both. So that's another confirmation that they're the same. If you have any trouble with figuring out these answers, just let me know. If you're not understanding what to read on the graph, and you can send me a picture of the graph that you got and the problem that you're doing, and I'll help you out. So let's go with number 13. Number 13 says cosine of x plus cosine of 7x equals 0. Okay, so it looks like I'm looking for the angles between 0 and 360 for which this equals 0. So I'm just going to graph this function in y1. Oh, I guess I could have addressed, there's a third option. You can do the y1 in this one, and then you can type in 0 into this one and find intersections as opposed to zeros, is whatever you want to do. I'm just going to do zeros. Cosine of x plus cosine of 7x. Let me make sure. Okay, cosine of x plus cosine of 7x. I'm still graphing on the window from 0 to 360, negative 3 to 3 on the y, so I'm going to press graph. And, okay. Interesting. There's a lot of answers here. Okay. What actually ends up happening is that a lot of these are just the same, they're equidistant apart from each other, which is fun. So what we're going to do is we're going to start finding our answers and see if they create a pattern, and then we'll go from there. I do kind of want to know if I dip down below right here, so I think what I'm going to do is I'm going to zoom in between, let's see, 0 and 60 degrees? Yeah? So I'm going to go 0 and I'm going to go 60 degrees, and I'm going to go every 15 degrees, and I'm going to go negative 1 to 1. So this is me. 15 degrees, 30 degrees. Okay, interesting. It did dip down below, so I'm going to find those two zeros, okay? Because I'm finding when this equals 0, I'm not finding intersections. Well, I guess I am. I'm finding the intersection with the x-axis. We just call those roots or zeros, okay? So second calculate, 0. Press enter to the left of it and then go to the right of it, which is below. Press enter again, and one of my answers is 22.5 degrees. So I don't know if you can see that, but 22.5 degrees. Okay, I've got another one right next to it, and I'm pretty sure it's 30 degrees. So 0. So left is below on this one. Press enter, and then I go to the right. You see how it's saying find where it crosses the x-axis between this one and between this. Right? So I press enter because I don't want to guess, and I get 30 degrees. Okay, so far I've got 22.5 and 30 degrees. I'm going to zoom back out. So second calculate, window 0 to 360. And I'm going every 15. I'm gonna go every 30 degrees, see what that's like. So we got those two. I need this one, this one, this one, this one, this one, and then it looks like it repeats. Okay. So here we go. Should have 14 answers. Second calculate, 0. So I want to find this one. I gotta find my blinky dude. Oh, he's way over there. Okay. Okay. So to the right of this root, right? To the right of this root, I need to be, to the left of it, I need to go up here. This is to the left, and then to the right, I'm just going to press to the right once, and it drops down here. All I got to do is be above and below, like mark above, mark below, press enter, because I don't, and then press enter again, I don't want to guess, and it tells me 67.5 degrees. So 67.5 degrees. And then second, calculate intersect, sorry, 0, and I'm going to find this one. So I need to be below, to the left is below now, and to the right is above, press enter again, I don't want to guess, and I get 90 degrees. Okay, so I've got 22.5, 30, 67.5, 90. So let's find the next one, this one right here. Second, calculate 0. To the left of it is above, press enter. To the right of it is below, press enter. I don't want to guess. 112.5. I don't know if you can see any of that. So I went to the left up here, and then I went to the right down there. 112.5. And second, calculate, I'm going to find the 0. So I need to find this 0 right here. Okay, so this one's a little tricky. I am below, because the y is negative right here, so I'm going to press enter. And I am still below, so I'm going to go one more up. And now that the y is positive, I know I'm above it, so I can press enter again, and I get 150 degrees. And then I've got one more on this side of 180, because this is right here in the middle is 180. So second, calculate in 0. I need to be above. My y value is positive. So as long as my y value is positive, I'm good. Press enter, and I go to the right, and now I'm below. I'm negative, so that's good. Press enter again, and I get 157.5 degrees. 157.5 degrees. So it looks like let's map this out on the unit circle. So far, my answers have been, I'm going to go with the whole number ones. I've had 30, I've had 90, and I've had 150. And then I've had 22.5. So if this is 30, this is 22.5. I've had 67.5, so here's 45 and here's 60. I've had 67.5. I've had 90. I had 112, so this is 120, and then 112.5. Then I had 150. Then I had 157.5. So it looks like to me I could probably guesstimate that the others are going to be, let's see, if this is, I think 210 is going to be an answer, and 202.5? 7.5 away? Let me check. So I think this one is 202.5. So I can calculate 0. Yep, 202.5 for that first one right there. So 202.5, and then I think the pattern is going to hold. So if this is 240 right here, it's going to be 7.5 away from that after it. So 247.5. Then I'm pretty sure 270 is going to be an answer. And then this is going to be 300, so 292.5 degrees. And then I think it's going to be 330 and 337.5. Let me check though. I'm going to check the, okay, so I can calculate 0. Enter, enter, enter. So this is 210. So 210. So I can calculate 0. I'm thinking the next one is going to be 247.5. So below, above, enter, 247.5. So I can calculate 0. This one right here. Press enter. Press enter. I'm pretty sure this is going to be the 270. Yep. So I can calculate the 0. Okay, so below and then above, find the intersect, or find the 0, and that's going to be 292.5. Good. 292.5. 0. This is going to be my 330. Sure enough. And then so I can calculate the 0, that's going to be my 337.5. And there we go. Okay. Now, as you recall, you are not taking a test over this, hopefully you recall. But were we to have a test over this, I would have limited and said, hey, find the answer between 0 and 90 or something like that. I would have narrowed it down because that's a heck of a lot of answers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 answers. Which we counted that off, so down. Okay, 157.5, 202.5 degrees, 210 degrees, 247.5 degrees, 270 degrees, 292.5 degrees, 330 degrees, and 337.5 degrees. What's going on here? Oh. Okay, so that comprises the list of solutions to that problem. Okay. It's kind of, this is a 7x and there are 14 answers. Okay. Let's do, I think I've got room for number 15 on here, and then I'll do another video, okay? So, number 15 says -4 cosecant theta equals 2 square roots of 3. So I'm going to solve for cosecant theta, and I'm going to divide by -4. So 2 square roots of 3 divided by -4. That simplifies to the 2 and the 4 simplify down to 1/2, and then I'm going to bring the negative up, negative square root of 3 over 2, right? So here's the thing. Cosecant equaling negative square root of 3 over 2 means that the reciprocal sign equals -2 over the square root of 3, and that's just not the case. If you look on the unit circle, I know where sine equals square root of 3 over 2, but not where sine equals 2 over the square root of 3. And in fact, it never will equal that, okay? Square root of 3 divided by 2 is less than 1, and cosecant, the reciprocal of sine, the highest and lowest it goes is 1 and -1, right? So, I mean, like, it goes above 1 and below -1, but it doesn't reach anything in between. And square root of 3 over 2, negative square root of 3 over 2 is between 0 and -1. Cosecant never equals it, so there's no solution to that problem. Now, I will say, I did ask you on 15 and 16 to find all solutions in radians. So this is one of those situations where, say I had been solving when sine equals negative square root of 3 over 2, right? So let's look at that. Sine equals negative square root of 3 over 2 at 4 pi over 3 and at 5 pi over 3. So my answer would have been 4 pi over 3 plus 2 pi n, where n is an integer, and 5 pi over 3 plus 2 pi n, where n is an integer, because every rotation, so it would be here plus another 2 pi rotation, and then I would get back to an answer. Plus another 2 pi rotation, I would get back to an answer, okay? So I just take my answer and I say plus 2 pi n, where n is an integer, and then there, I've got all solutions, okay? Alright, well that's the end of the first video, and then I'll pick it up at 17.